So yeah, we're going to talk about indoor industrial lighting applications and some of the different application considerations when working on a indoor high bay or low bay project. High bay isn't necessarily our main focus at Wisconsin Lighting Lab, but we do quite a few indoor industrial applications. Oftentimes, people pull us in when it's a challenging environment. It could be high temp, high dust. We've done some remote power applications. So we just want to talk through some of the things the sales team or our sales partners should consider when selecting products. So, I think the obvious one when selecting a light fixture for an indoor environment would be temperature. Why don't you kind of walk me through some of the temperature considerations when selecting the right product?
Yeah, I guess in industrial applications, you typically have a much higher ambient temperature at the ceiling than you do at the ground, and it's especially the case in foundries or places that have equipment that generates a lot of heat, and the locations directly above that equipment is even more susceptible than the rest of the facility to a much higher ambient.
Yep.
So, you just have to make sure to keep that in mind when you're specifying products.
Yeah, I know when we a few years ago we did an application for one of our part vendors at their facility up in Oshkosh. Pretty big facility. They do they have hundreds of thousands of square feet, multiple shift type operation, and they originally installed some lighting products. It was a linear high bay product, and whoever had provided that solution didn't properly consider temperature. And we replaced some of the fixtures with our EcoBay fixture, and really for several years we haven't had any issues. And the same with our facility here, same type of product, but it's just high bay. A lot of people think about a warehouse the same way as they think about an indoor facility, and like you said, on the temperature side, it's a lot warmer at the ceiling than it is down by the workspace.
Yeah, and another thing with that customer you're talking about, they had a bunch of those fixtures put up, and they kept getting dust and dirt on the inside of the lens, and so they would, instead of going up and cleaning it regularly, they decided to tape off the whole top of the fixture, right, which also added to a lot of the thermal issues that they saw. But, having products that, don't have openings on the top that are going to compromise your light output are important.
Yep. Yeah, and we, to address those issues on the temperature topic, we have a couple of different design considerations. Number one is we often use a lot of heat sinking for high temperature environments. So the same heat sinking we use for like a high output sports application, we use that same proprietary design for an indoor environment, and we also turn the drive current way down. So that gives it a higher elevated ambient temperature. But to your point you just made, why don't you talk about the LED optics compartment for the products that we use silicone optics on?
Yeah, so products like the Helios and the EcoBay have
the new HDX as well.
Yeah, the new HDX have silicone optics, and they have the heat sink on the back. Everything is sealed the same as if it were an outdoor fixture, so nothing, water, dirt, dust are going to get into the LED compartment, and all the products are rain tested and dust tested. We have pass-through heat sinks so that any dust that falls on top of these products, it's going to fall through the heat sink to not compromise any of the thermal properties that we have.
Yep. And we've been using that design for interior applications for 5 or 6 years now. And so we've had very few issues when it comes to temperature in LEDs. Drivers are sometimes another story depending on the environment. And I think a lot of driver issues, people think it's temperature related, but it's probably more due to power issues, which is a big concern in an indoor industrial environment. Our assembly here or our plant here in town is primarily an assembly, final assembly facility, so we don't have a lot of heavy machinery. And oftentimes in environments where you have heavy machinery, there's a lot of startup and shutdown of the equipment, which can cause problems for solid state lighting. So I think what's sometimes a temperature related driver issue is really a power issue, and I don't know if you want to talk a little bit about that. Which, if the first consideration is temperature, I would say the second consideration would be power quality within the facility.
Yeah, I mean, when you think of industrial facilities, they have motors on most equipment. They have large ovens or heat sources that are firing up. A lot of these foundries have big electrical foundry equipment that is going to suck a lot of electricity instantaneously out of the system, and then you're going to have these dips and peaks on every time that they run the equipment. And we had a customer that had installed a bunch of our Helios lights on a crane, and every time they run the crane, the lights would flash, and it was because the motors on the crane were drawing power and stuff wasn't properly grounded. So you can have a lot of electrical issues on indoor applications.
Yep. Yeah, and there's things that owners and customers and end users can do to help with some of that, but I think it's most they have to be aware that it's an issue, and I think the industry is starting to become more educated around around some of that, and especially industrial manufacturers that have had solid state equipment for a long time. They've been forced to have power conditioning and other things at the panel to help clean up the voltage. But I think some of the other, like some of the foundries where there's maybe not as much, I think there's probably some computerized equipment, but a lot of that stuff is still just like older equipment with with larger motors and things like that.
Yeah, and it's hard to educate those types of people on how more sensitive the solid state stuff is than their old HID or metal halide stuff. They don't care so much about those dips and peaks, but
they've been used to it's part of their maintenance program has been servicing HID lighting, and I think the expectation is that the new fixture will last forever. So we've had some applications where we're very, very upfront with people. It's like if this thing is running 24/7, 365 in this type of environment, if you start to see certain types of power supply issues, that might be a sign of other issues. And we've if you can have good dialogue with the customer and explain solid state lighting versus conventional lighting, it's nice to get on the same page. So, but definitely the second consideration would be power quality at the facility. So the first one's temperature, second one would be power quality, and that's not always something you know about right away. So what we've done with some of our recent designs is ensure that the driver replacement process is easy. So if there are issues, with their power quality, sometimes it's easier just to have a program to easily replace the driver than it is to completely change their electrical infrastructure. So temperature, power quality. I would say another one that we run into is chemical compatibility in the air. We've done some indoor natatorium and pool applications, but why don't you walk through some of the considerations kind of within the chemical umbrella?
Yeah, I guess having our sealed optics, we are pretty fortunate in not having a lot of chemicals be able to penetrate the LED compartment. So sometimes if there's a chemical compatibility issue, it can discolor the LED. It's still going to output a light, but it can be green, it could be purple.
We've seen that in Milwaukee and
for sure
all the roadway failures right now.
Yeah, so as long as we're not introducing the chemical into the system during assembly, we're typically in good shape. And as far as like chlorine, again, it doesn't penetrate through the silicone optics that maybe it would in some sort of other assembly. So we're able to have installs in these different locations that may have some chemical in the air. And we try to do our due diligence when a job like that comes up, that we check and see like what chemical might be in the air, like chlorine, if there's other chemicals in the air.
If we're aware of it on the front end.
Yeah, it's always good for us to know, so we can do a chemical compatibility check on all our components that could possibly be exposed to it, whether it's like our wires, the optics, just gaskets on certain parts. We just want to make sure that kind of stuff isn't going to have any issues in long term.
So when we talk about chemical compatibility, and a lot of this is speculation, but I think it's pretty much known what the problem is. But right now with a particular fixture, and it's not our fixture, fortunately, but there's several thousand lights in the city of Milwaukee that are turning purple. And about once a week, I'll have somebody shoot me a text, or somebody will ask me, hey, what's with these lights that are turning purple? Are they supposed to be that color? Are they supposed to be that way? And kind of explain to them that, what could be happening is there's outgassing that's happening once the fixture fires up. And what is it? What's the outgassing term?
Like VOCs.
VOCs. It's like when you paint the wall in your house for the first few weeks, you're going to smell the chemicals. So if that happens upon initial fire up, and the gases get trapped underneath the optic, and maybe they clean the optical surface with some type of a cleaner that was not compatible, that can actually ruin the phosphor coating on the outside of the LEDs. And it is the purple, the LED's natural state. Is it
yeah,
purple?
a white LED is actually blue or purple to begin with, and then they add a phosphor coating that filters out all of the blue light, and you're left with the white.
Okay, so that's likely what's happening with those fixtures. So, but yeah, that was usually not a consideration that's needed for roadway.
Right,
is chemical compatibility. But when you think about the environment that the LED is inside of the trapped optic, that's doesn't like it. So another one would be debris. We've run into this with a recent application. Our fixtures they're pretty solid. They're pretty stout chassis and heat sinks and everything else. And we really haven't had too many issues when it comes to flying debris, but it can come up in foundry environments and other types of environments. I guess there's certain compliance and certifications that some manufacturers are starting to go through to relay the quality of the fixture. But I guess what from a construction standpoint, what have we done to ensure it's as durable as it can be?
Yeah, I guess the main thing is having silicone optics. That if they get hit by something, they have give to them. They naturally absorb most of the impact, and there aren't filaments or any glass that's going to break on impact, so you don't have to worry about things like that happening. But just having that silicone optic is a big help.
In a lot of high bay designs for warehouse environments, it's a piece of thin sheet metal with an acrylic or a polycarbonate lens over the top that is more or less just using gravity to hold itself in place. And we have some designs. We have a new design like that for less intense environments. But it really comes down to, if you're going to be in a heavy industrial environment and there's going to be debris, every component on that fixture, better be fastened pretty well with hardware.
Yeah.
As opposed to just using gravity to hold the lens in.
And we use a lot of automotive grade connectors that are designed for bouncing down the road for thousands and thousands of miles.
Yep.
And
the drivers are potted.
Yeah, everything's fully potted, so they absorb all the vibration and impacts as well from objects, I guess.
Yep. So another consideration is you hear this term thrown around a lot, not necessarily for high bay applications, but more indoor office spaces and museums and other applications like that, but like human focused or human centric lighting. And I think when it comes to high bay, I think glare management is definitely a consideration, and just a lumen bomb at the ceiling is nice, but at the same time, it's also nice to maybe diffuse some of that light so it's easier to look at. So what are some of the things that design changes and things we've done over the years, and also when an applications team or a sales team is looking at a particular job, when it comes to making things kind of human focused, easy on the eyes, what are some of the things they should look at?
Yeah, I guess fixture height is probably a big deal as far as how much glare there is. Having more fixtures is another thing they want to consider. Instead of having like one really bright light in a 20 by 20 area, maybe you need 3 or 4 spread out just to get the light spread out. The other thing, thermally, we turn down the fixtures so that they work better in indoor environments, and that lends itself to have less glare because we've turned the drive current down, and we can also do some PMMA or acrylic lens that's diffused in front of some of our products so that it diffuses all the LED light, and we can also do like glare grid. But all this should probably be talked about on the front end, as we've discussed.
Yeah, absolutely. In the diffuse lens, there is a trade-off there when it comes. There's actually probably two major trade-offs. One would be the efficiency of the fixture goes down, and it changes the lighting distribution of the optic.
Yeah, and we're going to have to turn that down as well. So you're losing efficiency, you're losing lumen output because we have to turn it down farther so we don't compromise the thermal properties. And then, like you mentioned, the distribution.
Yep. Okay. We also have indirect options. We've done quite a few indirect lighting applications, and it seems like tennis and pickleball and a lot of those sports are increasing in popularity. So we're doing a lot of indoor applications and designs, which if they have reflective ceilings, it's a nice option.
Yeah, for sure. And if you're using something like the KB4 as an indirect uplight, putting it upside down creates pockets, so you want to be sure to have glare grids, or not glare grids, wire guards, so that no balls or anything can get stuck on top of the fixture because they will start on fire.
Yeah, that's definitely a consideration. We've done many years ago. I remember doing a indirect job, and we went to inspect the application, and you looked inside the light, inside the visor, and it's like, oh, there's a baseball, there's a tennis ball. So definitely important to have those wire guards on there. I guess the last thing would just be different types of compliance. And we don't necessarily have to talk about specific compliance. We know there's a lot of options out there. But when you think about compliance, it's really a way for us as the manufacturer or the specifying engineer to relay certain information in a fast way to whoever's in charge of buying or selecting the products. What categories do you put compliance in? Is it safety, performance, and reliability, or how do you think about compliance, both as an engineer selecting parts that go into finished goods, and then if you are a specifying engineer selecting our fixtures for your application, like how do you approach that?
Yeah, I guess first and foremost, you want to make sure that they comply with safety requirements.
And in our world, safety typically is UL 1598.
Right.
That's indoor and outdoor?
Correct. And there's dry, damp, and wet location ratings within 1598. There's also a marine rating, which is 1598A. But you just want to, from a specifying engineer standpoint, you got to check that box. If it doesn't check that box, it's just not probably going to happen. I guess the performance side of things kind of goes also with DLC and longevity, because DLC is testing the overall performance of your fixture, but you can't get DLC if you don't have safety testing. So I guess specifying engineer, if he sees that it's on the DLC listing,
you can assume that
it has the safety requirements.
That's a good point.
Need. But they check how long a fixture is intended to last, like L70 or L90 hour, so 90% of light output or 70%, how long that takes, and they have minimum standards that you have to hit to be able to be on DLC. And
DLC in reality, it's kind of a shorthand for both safety and performance. If you think about it. Okay. Yeah, and then you have so again, it's safety, which is in our world is typically UL 1598 for either dry, damp, or wet locations. So that's within safety testing. You have performance testing, which is light output, lighting distribution. What else is within performance?
Color, CRI, CCT, like all that stuff gets measured during performance testing.
Yep, and then you have DLC, which is kind of in theory, a combination of both. And then we have reliability testing. So that would be things like vibration testing and some of the impact tests out there.
Yeah, so you have impact testing, you have vibration testing, you've got lifetime testing. Just having product in use, we install a bunch of our product here locally,
Yep.
and it gets run every day, all night. You know, we have it in our facilities, we have it outside of our facilities.
Local sports fields.
Yeah.
Yeah. Yep.
So, you know, that's part of lifetime testing, is making sure in application everything, because you can rain test a fixture and it's great here, but you go put it out in the wild for
Get
a
it
few
in the real
years,
world, right?
and you all of a sudden all these issues come up. So,
Well, cool. I think that's a pretty good overview. I think I think indoor heavy industrial environments, you know, aside from water, although we do have some applications where we've done indoor, you know, there's like wash down ratings and things like that. But when you think about that environment where you have high temperature issues, you have debris, you have, you know, power quality considerations, you have impact, you have chemical compatibility, you know, those really, I would say, stress test a platform about as much as any platform. You know, I think the cool thing about the way that we approach our designs is the things that we learn in these environments get applied to outdoor environments as well. You know, in a similar way, you know, the things we learned for outdoor get applied to indoor, such as the optics and the sealed, you know, electrical compartments, you know, for the LEDs and things like that. So, anything else to touch on, or is that
no,
that
I
cover it?
think that's good.
All right, man. Thank you very much.
Yeah, thanks.